Hey everyone, in this video we're going to look at how to make an endless 3D runner like Subway Surfers and Temple Run and games like that. So first you need to get your 3D models in the asset area of the project. So I already posted a video separately showing how to create the assets using Asset Forge. You can use whatever you want. And you simply save them in OBJ form, and for every object you create, say like the bricks, there's going to be a corresponding material file. Make sure you drag and drop both. So for every OBJ, you also need the MTL for it. And again, it's just a material file. It's just highlighting and then drag and drop right into the area. Okay, so let's take our main tile object and put it into the scene. Now I'm calling this a tile. It's a 3D model, but you're going to use it like a tile because you're just instantiating, you're spawning the same object over and over again. So a little bit of housekeeping first. Don't know why Unity does this. So it created the 3D object, okay, the object with the 3D model, and it gave it a transform component so it has like position and you can do rotation and scaling. But for some reason, Unity also creates this top level, this parent that's empty and also has a transform. And I can't figure out why it does that because there's no functionality to it. There's no purpose to it because we already have a transform here. So let's just choose Unpack Prefab. Left click, drag the 3D model away, and delete that empty parent. You technically could use it. I just think it makes it more confusing to see it because, again, I don't see any functional purpose to it because this object has a transform component. So let's just rename this. We'll call this tile 1. We'll take that and we'll drag it into the scene. And now you have what's known as a prefab. This can now be utilized by objects within the game to be spawned, instantiated, or whatever else. So now what we're going to do, I want to take a minute to point out something, and this is very important to make your life very, very easy. This center part where the player is going to be is exactly 3 by 3. And by 3 by 3, I mean 3 by 3 Unity units. So it makes positioning really, really easy. So for instance, if I take a game object and I do 3D object and I make, say, a sphere, I know that the center of this is 0, 0, 0. So if I do 0, 0, 0, it is exactly where I want it to be. So if the character moves over one lane, it's going to be -1. If he's in the middle and he moves over the other direction, that would be +1. So it's really easy to know exactly where your player should be. And second of all, we can delete that. That was just for demonstrative purposes. It makes it really easy to know where the next tile should be spawned. Since this is exactly 3, then that means the next tile should be placed 3 further. So this one is 0. So if we copy and we paste, all I have to do is change this to +3. So again, it makes it really easy, really predictable is where it should be placed. So that's the only thing that I want to call out when you're making your 3D models, especially the tile. Think about how it's going to be used and how it's going to functionally impact the game. And in this case, you want an area that's very predictable because that's like 95% of the control is where the player is going to be and where the next tile is going to be placed. It also lets you know where objects should be placed on the tile. Likewise, if you want some rubble to show up, well, if you want to show up here, you know the x is -1. If you want the rubble to show up here, you know the x is 0, on and on and on. So that's really the most important thing that I want to mention. I also want to say that when you're designing it, make sure that one end matches nicely with the other. That way, when they're sequential, you don't see any kind of rough break there. So let's go ahead and delete those because that was just for, again, demonstrative purposes. And now we're going to make the 3D environment. So we're going to right-click, create, C#. We'll call this game flow, and we'll attach this to an empty GM object. So game object, create empty, rename this GM. Now, being called a GM means absolutely nothing, and you can do this without a GM object, but I like having a GM object for organizational purposes because I can click on that and I can see exactly what scripts are attached to it, so I know which ones are impacting the scene that's running. So let's just go ahead and put the script on the GM object and open it up. Like I said, this is going to take about 8 lines of code. You can get rid of this. The double / indicates that is a remark statement. It is not being executed. It simply is internal documentation. Same for this one. Okay, so the instantiate command uses 3 arguments. What is being instantiated, where it's being instantiated, and the rotation. So we need variables for 2 of those. So first one needs to be public, so it's accessible through the inspector. So public transform, and it's going to be tile1 and then obj. I just like to append obj to game objects when it's an actual object and not just like a variable or something. That way I know it's referring to a 3D model or 2D model or something like that. Next one can be private, doesn't need to be in the inspector. Whoa, that is some terrible typing there. Private, and this one will be vector3, and we'll call this next tile spawn. Now we're going to have to set a value to that, which we'll get to in a minute. So basically we're going to put the broad strokes here and then go back and kind of detail it in a little bit. So now what we need is the coroutine that will run again and again and again to keep generating those tiles. So IEnumerator, and it's going to be spawn tile. So yield, return, new, wait 4 seconds, and a certain amount of time. We'll use 1 for the moment, might have to go back and change it. Again, just the broad strokes to get the functionality in place. I usually like to explain every little thing. You do have to type yield return new. Don't worry too much about it though. As far as the big takeaway for this line, wait 4 seconds. You're saying wait a certain amount of time, measured in seconds, and then something will happen, which will be the subsequent command. So we're going to say instantiate. Well, what are we going to instantiate? Again, 3 arguments. We're going to instantiate the tile obj. Then we have to say where it's going to be instantiated. So it's going to be instantiated next tile spawn. And then it's going to be the rotation. So tile1 obj dot rotation. So what's being spawned, where it's being spawned, and the rotation of it that's being spawned. This means use the tile object's own rotation. Don't change it because sometimes you may want to. Sometimes you may want an object to be rotated based on what's doing the spawning. So in that case, I would do transform.rotation, the rotation of what this script is attached to, which is the GM object. But again, we don't want to do that. We want the rotation of the tile object itself. Okay, so now what we need, once this gets executed and it instantiates a tile, we need it to increment where it's instantiating that tile and then go back and repeat. So 2 things. We need next tile spawn dot z, that's the one that we said is the depth, plus equals 3. Now, since we didn't give this any value here, it should start off at 0, 0, 0. If for some reason it doesn't, we can just enter those values there. But usually when you create a variable, if it's a number, it'll default to 0. If it's a string, it'll default to like blank or null, that kind of thing. So what we now need is so there was a wait. It instantiates the next tile that you're going to come across, changes the value, increments it by 3, so that way when this happens again, it'll push it out 3. Now we just need this to rinse and repeat. So start coroutine, spawn tile, parentheses. Oops, parentheses. So now that makes this an infinite loop. And this is exactly what we need up here in the start section to go down there in the first place, because this will never, ever, ever execute on its own. You need to at least once say, go ahead and do it, and then it will then run itself at that point because of this, creating the loop. So, like I said, doesn't take many lines of code. We're almost there. So what we need now is, at the moment, the screen is blank. So we need a few tiles here to begin with. So we can either drag and drop the tile a few times into the scene, or we can put that in the start section, 6 one way, 1/2 dozen the other. I'm going to put the first few tiles into the into the scene. That way we can line the camera up. So here's our GM object. There's the tile 1 object, so we have to put the tile 1 on it. And now we'll take this and put it in the scene. So 0, 0, 0, great. Put the next one in there. That will be 0, 0, 3. Put the next one there. 0, 0, 6. Put the next one there. 9. And again, yes, you could do these in the script in the start section, but like I said, this will help us line up the camera. And then I think one more will be enough to do it. Okay, so if this one is 15, I'm going to go back to the script for a second. Then that means the starting value for this needs to be 18, because again, we're incrementing by 3. So in the start section, we want to say next tile spawn dot z equals 18. So when this happens, it'll spawn at 18 and then go to 21 and so on and so forth. So we'll save that. So now let's take our camera and line this up. Now you really don't want to be high up that for a couple reasons, because A, you're really not getting a good angle on the action. You really want to be pointing down. Also, by looking up, you're creating all this empty space, which you now need to fill up with something. You could put a skybox or something there, but honestly, it's not a great angle. So it's one of those happy coincidences. By pointing down towards the scene, you get a more appropriate angle, and it cuts out all that kind of dead space there. So we do that, and then we just maneuver this. Let's get closer to the track. There we go. And actually, we can get a little bit closer. Again, I'm trying to make sure there's no dead space showing. Okay, so I just clicked on the game tab, so it's not running, but this is what it'll look like. So far so good. Only problem is, since there's a 1 second delay, I think we'll get a gap there. So let's actually not recalculate, but we'll put one more out here. We'll put him at 18, and then we'll just change this to 21. Okay, let's see if I forgot anything. So we have the tile object. We have the vector 3. We set it to 21. We say to spawn more tiles. It waits 1 second. It spawns the tile, increments this by 3 because we said it's 3 deep, and then rinse and repeat. So, last thing to do for this video then is the camera. So what's going to happen is, in a later video, we'll add the player, but the player and the camera really need to move in tandem. So what we're going to do, we're going to create another script. So right click, create C#, and we'll call this cam move. Click on the camera. Sorry, I took the game flow script. My apologies for the confusion. That's the one I meant to grab. So camera, cam move, open that up. Again, you can get rid of the remark statements. They're not executed. Now, for the camera to move, it needs to have what's known as a rigid body. So with the camera selected, add component, and we do physics, and we do rigid body, and we undo gravity, or else the camera will drop down towards the ground. Now we just want the camera to move forward at a certain speed. We'll probably eventually have a variable here, because usually the way endless runner games work is that the rate in which it's moving gets faster and faster, but we'll keep it simple. I just really want to look at the spawn rate of the tiles right now. So get component, rigid body, velocity, and it should be, it's not moving along X, not yet anyways. But like I said, when you have a character and they move left and right, you might want the camera to move left and right as well. It's a design choice. So 0, whoops, sorry, my apologies. Really messing this up. Equals new vector 3. My apologies about that. So it's a vector 3, but you have to declare the velocity for X, Y, and Z. So we said camera's not going to be moving at X. It's not going to be moving Y higher. We might add ramps or something, and then your camera would move up as your player moves up. Oops, sorry, I don't want Y. We want 0. And then Z is going to be, at the moment, a constant. But like I said, it's probably going to be a variable. And that variable will increase that way as the game progresses. It moves faster, because that's one of the main challenges. So let's make it a positive 3. So my apologies. When I was typing that, really botched it a few times. But so it's get component rigid body velocity equals new vector 3. Now what I think is going to happen is we'll see a gap there, because I don't think it spawns fast enough. So we might want to put one more there. Nope, it looks like it is spawning fast enough. So I kept my word. It took about 8 lines of code to make an endless runner environment. So the game's not done yet, obviously, but it's going to keep going. So we have essentially an endless environment now. It will just keep spawning that over and over and over again. Okay, so yeah, yep. I just noticed a little bit of flicker at the top there. I didn't notice it at first, but there's a little bit of flicker, so technically not quite right. So it's showing it just in time, but you don't want it to be that close. So you could do a couple things. A, that speed might be too fast that the camera's moving. If it's moving slightly slower, then it won't be a problem. But it looks like right now, the rate of the camera and the rate of instantiation is almost exactly right. It's almost exactly matched. You can move one more tile out if you wanted, and then that would be gone. But that's one of the things that you'll test on and on and on to make sure that you don't ever get those blank zones. Another thing that you can do is, rather than instantiating just one tile, you can instantiate 2. So you would instantiate at next tile spawn, and then you would break down next tile spawn into its 3 components. Actually, no, you wouldn't even have to do that. You know what you do? You would just add 3 to this again. So what you would do is you would add another instantiate here, exactly the same coding. So let's go ahead and do it. But then you have to make sure you increase this a second time. So and we'll run that one more time. See, I didn't see the blip at first. Yep, that took care of it. So rather than spawning one tile, you spawn two. You just have to make sure you do the addition twice. Okay, so I think that's it for this first video. In the next video, we will have the debris spawn, and it's just derivative of the same idea that you create a variable to track so this one tracks the tile object. The next one would track, say, the cart or the crate. And just as you instantiate this, you would have a separate instantiate command as far as where you're going to put the debris. So you would use the same next tile spawn value, except you would have to bring out the X. So you would have to change the X value in that. So whereas right now we're manipulating the Z, we'd have to change the X value for the spawn of the object, the debris. So maybe we'll create another variable to track that as well. Okay, so I hope you found this helpful, and I hope you enjoy the rest of your day. If you have any questions, if there's more you want to see, just let me know. But like I said, in the next video, we'll add the spawning debris. Since it's so similar to this, it probably won't take the whole video, so we'll probably add in the running character too and work on their control. It's actually pretty simple. It's just, did they press A to go left? Did they press D to go right? Did they hit space to jump? That kind of thing. And then it's just kind of fine tuning. So it's actually that easy to make an endless runner game. So again, hope you found this useful, and I hope you enjoy the rest of your day.